Alright, so in this video, I'm going to give you four problems about central and inscribed angles. And before I give you those four, let me first discuss to you the two theorems that are very important when it comes to solving problems about central angle and inscribed angle. So theorem number one is this one. The measure of the central angle is equal to the measure of its intercepted arc or subtended arc. So if in this case, if we have an angle AOB, which is the central angle, let's say that's 30 degrees, that means AB, arc AB, is also 30 degrees. That's the meaning of that. Theorem number two, here it says the measure of an inscribed angle is half the measure of the central angle that subtends the same arc. So here you can't see that central angle, so I'm going to draw that first. Okay, so let me just... So let's say this is a central angle, and let's say the measurement of that central angle is 80 degrees. It says, according to the theorem, that half of that is the measurement of this. MON, the measurement of MON, angle MON, is half of the central angle 80, which is, in this case, it's 40. Alright, so let's apply that to solve the following problems. Problem number one. In a circle O with the measurement of angle AOB, which in this case, as you can see, it's a central angle. It's 38 degrees, it says there. Find the measurement of the angle ACB. So ACB is right here, and obviously this is an inscribed angle. All we need to do is to find the measurement of arc AB first. Since the central angle is 38 degrees, that means AB is also 38 degrees, which going to give us the value of angle ACB. So the measurement of angle ACB is equal to half the measurement of angle AOB. So that means 1/2 of 38, which is equivalent to 19 degrees. All right, let's go to the next one. Here we have again a circle O, and the given is the measurement of angle MPN, and this time the inscribed angle is given, which is 20 degrees. What we want to know is the measurement of angle MON. So in order for us to know that, we need to know MN first, because that measurement of that arc is the same as the measurement of the central angle. So according to the theorem, half of MN is equal to the measurement of MPN. MPN is given, which is 20 degrees. So meaning twice of that is your MN. And that's going to give us 40. So that if that is 40, then that means the measurement of angle MON is also 40 degrees. So the measurement of angle MON is actually twice the measurement of angle MPN. So that means twice of 20, which is equal to 40 degrees. Alright, let's go to the second to the last example. Here we have the central angle given, which is COD, and that's 108 degrees. And then our arc is given, and it says it's equal to 15x plus 3. Now they're equal, so that's our equation. 15x plus 3 equals 108. Alright, so let's cancel the 3, subtract, add -3 on both sides, so that's plus -3. So 15x equals 105 divided by 15 on both sides. 105 divided by 15 is going to give us 7. So here x equals 7. Let's go to the last example. Here we have an inscribed angle, which is 74. Okay, and then we have the arc, okay, AC, which is 14x minus 20. Now you may be thinking, oh, they're equal. They are not. Remember, half of that AC is equal to ABC. Half of arc AC is equal to the measurement of angle ABC, which is the inscribed angle. So that's our equation, meaning 14x minus 20 divided by 2, half of that, equals 74. So first step, multiply 2 on both sides. So that's 14x minus 20 equals 74 times 2. That's 148. And then plus 20 on both sides. 14x equals 168. And then finally divided by 14. So 168 divided by 14 is equal to 12. So the value of our x here is equal to 12.